All right, so it's a wrap up of the last activity of week 1, which is angular motion. All right, and hopefully in this one you learned how to use pivot. Okay, but should have looked something like this. Okay, so you were getting the angle in radians. All right, and I suppose everyone's far enough along in math that we know, right, when we're looking at a circle, 0 degrees is the same as 0 radians. Every time I go around the circle, that's 2 pi radians. Okay, 2 pi is going to be an important number. All right, so every revolution you make is 2 pi radians. All right, also 360 degrees, but we don't use that as much. All right, so there's a lot of this kind of stuff. One revolution means once all the way around would be 2 pi radians, because the angle that it would rotate through would be the full unit circle. All right, so hopefully you did this, so you should have labeled this like 0, 2 pi, 4 pi, 6 pi, 8 pi, whatever, if you did it in radians, which I think you did. All right, and then if you started it wherever you arbitrarily called 0, all right, and then you should have your line like this. All right, now hopefully you recognize this as very similar to what we just did with linear velocity, okay, but now we're doing angular. All right, so there's a couple different ways to do this in physics. A lot of people like to do all the linear physics first, then go back and sort of review and do all the angular. But I found it better, and my kids last year liked better, that we'll do linear and then we'll do the angular component to that, or like the angular, what do we call that? Like analogy to that. All right. That also will be better just in case something happens and they cut, stuff off the test, or we kind of have to cut the year short again or something, then, because angular is hard. That's what makes it all really hard. So we'll kind of ease into it as we go. Okay. So linearly, we had this as our main equation. Okay. And then as you can hopefully see, you have the same idea here with your y equals mx plus b, but your y is your theta final, that's your angle, equals some slope, which I don't know what yours was, whatever, I'll just say 6 radians per second, okay, times the time plus 0 radians. All right, so exactly like the linear, every angular has like a corresponding linear that is literally exactly the same. Okay, so in this case, this 6 radians per second is not telling us the linear velocity, it's telling us the angular velocity. All right, and that is a lowercase omega, looks like a W, lowercase omega, okay? And that again is going to be the average, same as it was before, times the t plus, you guessed it, theta naught, or the initial angle. All right, so this is your new equation. All right, this is called the average angular velocity, and it's just basically telling you how quickly something is rotating. Okay, so instead of something moving like this side to side, this would just be something moving around and around and around in a circle. All right, other than that, everything is exactly the same. All right, so when you're explaining your slope, 6 radians per second, you would say for every 1 second of time that passes, the angle increases by 6 radians, or whatever your number was. Okay, and your theta naught, 0 radians, would be when the time is 0 seconds, the angular position, or the angle, is 0 radians. Okay, angle, angular position, you say however you want. All right, so notice though that these two equations are like literally exactly the same equation, right? But instead of x, you have theta, and instead of v, you have omega. All right, so moving on to solving some problems in that. Hold on, let me see if I was going to make a different. Oh no, I'm going to make an example for that, so never mind. Okay, I think that's all you need to know for this lab. All right, so it should be exactly the same. So hopefully you're kind of getting this idea of how you pull these equations from the graph, because we're going to do this a lot. These ones are simple. They'll get a little tougher. All right, if you have questions, make sure you ask me.